welcome back for video 3. We're going to talk about compound names and formulas. So when we have these different compounds, we have to know what to call them. And there's different ways to refer to a compound. Just like all living organisms, all organisms usually have a scientific name and a more common name that you and I would know them as. For example, salt. We know salt as table salt, but it's known scientifically as sodium chloride. French fries taste much better with some sodium chloride added to them. Chemists and scientists have developed a system of naming things. And this is a set of rules called the chemical nomenclature. And this chemical nomenclature, it's standard all over the world so that all scientists everywhere know how to refer to these compounds that they're all looking at and nobody gets confused. A binary compound, binary means two, and has two elements such as sodium chloride. Or in this slide, we have aluminum and fluorine, so a metal and a non-metal coming together to form aluminum fluoride. And if you remember from the last video, the metal and the non-metal form an ionic bond with each other. So there are different rules for naming these compounds. Oh, and here we have some other examples of binary compounds. We have sodium chloride, and we have C2H6, which I don't off the top of my head know what that one is called, but we could certainly look it up. And then we have C6H12O6, which we also know as glucose. And this is not a binary compound, it's a trinary compound. Actually, I don't think that's true. It's something else with the tri name, because tri means 3. So we'll probably figure that out as we go. Okay, so in naming binary compounds, we want to follow the rules that have been laid out for us. You want to use the full name of the metal first, and then you use only the stem of the non-metal second. And you add a suffix, "ide," to the second name, which is why we have sodium chloride instead of sodium chlorine. So we started with the metal and then we added the non-metal and we changed the ending. So sodium chloride, and we have K3N, which is potassium nitride, and so on. So there's many, many different kinds of compounds, and there's rules that are followed for naming these. Here we have a binary molecule, which this is a binary molecule or a compound, but we know it just as water. And here we have sucrose, which is another type of large organic molecule. So a chemical formula tells us what a compound is made of, like the kinds and amounts for each element. So going back to the water, the chemical symbols are used to represent each atom. So for water, we have 2 atoms of hydrogen, so H2, plus 1 atom of oxygen, and together they equal 1 molecule of water. So table salt, we have, again, sodium chloride, and we are very familiar with several of these formulas already because we've already talked about them. The formula H2O, again, it means that there's the 2 hydrogens and 1 oxygen atom. And so we have these little numbers here, and they are called subscripts, and they're added in there to mean that there's 2 of that atom. The subscript after an element symbol always tells us how many atoms of that element there is. And sometimes there's more than one of a type of a molecule in a formula. Then a number goes in front of the molecular formula. So we could have two in front of the H2O would mean we have 2 molecules of water. So here again we have sucrose, and this is a larger molecular formula. We know in this molecule of sucrose that we have 12 carbon atoms, we have 22 hydrogen atoms, and we have 11 oxygen atoms. And that's what forms 1 molecule of sucrose. So in this type of molecule, we have 3 different elements. And if you add up all of them, you can find out how many atoms are involved in this molecule, and you could draw it out. Okay. And that is it for video 3 and for all the videos for this week. Have a great week.